Hello everyone. In this video, we will see what is 0-1 knapsack problem and to find the solution by implementing dynamic programming. What is a knapsack? So knapsack is like a container or a bag. So in this diagram, you can see a bag which is a 20 kilo of weight, and we are having some certain items, and each item has its own weight and has its own value or the profit. So the problem here is we have to carry certain items inside the bag. So for this problem, we have to follow two conditions. One is we have to carry certain items inside the bag so that it produces the maximum weight, maximum profit. And the second condition is the items that we carry inside the bag should be less than or equal to the weight of the bag. So these are the two important conditions. So that should be followed to find the problem, find the solution. So here we cannot carry all the items because it exceeds the weight of the bag, which is more than 20. And also we do not know what are all the items that we could carry so that it maximizes the profit. So to find this, we are using the 0-1 knapsack problem. We have certain formula so that by implementing the formula, we can find what are all the items that can be carried so that it produces the maximum profit. So why it is called as 0 or 1 knapsack. So here the items that we are carrying should be a whole item. So we cannot carry a half of the item. Either we should carry that item or we have to leave that item. So if we carry the item, we call it as 1, and if we don't carry the item, we call it as 0. So we cannot carry the fraction of the items. So we'll see with an example. So before that example, we can see what is the formula. So the formula given here is T of I comma j is equal to maximum of T of I minus 1 comma j comma the value of the item plus T of I minus 1 comma j minus the weight of the item. This is the formula. So in this example, we are having a bag which has a weight of 5 kilos, and we have some 4 items, 1, 2, 3, and 4. And each item has its own weight of 2, 3, 4, and 5. And again, each item has its value or the profit is 3, 4, 5, and 6. Now, initially, we have to construct a table. The table here in the table, the rows are considered as the items I, and the columns are considered as the weight of the bag, which is J. And here you can see the first row and the first column are filled with zeros. That means initially we don't put any items inside the bag. So initially the bag is empty. So that denotes that initially we have zeros. Similarly, the weight of the bag is also 0 because no item is inside the bag. So initially it is 0. So we can give zeros to the first row and to the first column. Now we have to find the value that should be entered in this cell. So for finding that, we are going with T of 1, comma 1. So we are naming this table as T. So T of 1, comma 1. So for finding this particular cell, we are taking the values as I is equal to 1, and then the value of I, a value of 1 is 3, and the weight of 1 is 2. So we are just substituting all these values inside this formula. So here T of 1 comma 1 is equal to maximum of T of 1 minus 1. So I is 1 minus 1 comma J is also 1 comma the value of 1. The value of 1 is 3 plus T of 1 minus 1 comma J minus, that is 1 minus the weight of that value, weight of that item. So here we will have maximum of T of 1 minus 1 is 0 comma 1 comma the value of 1 is 3, so 3 plus T of 1 minus 1 is 0 comma 1 minus the weight of the item is 2, so 1 minus 2. So here the resultant will be maximum of 0 comma 1 comma 3 plus T of 0 comma minus 1. So you can see the table of 0 comma 1. So the table of 0 comma 1 is, here we have 0 comma 1, which is equal to 0 comma 3 plus 0 comma minus 1. So we don't have any value or any place as 0 comma minus 1. It is indefinite. So we can neglect, we can ignore this particular value. So here the value of 0 comma 1 is 0. So we have T of 1 comma 1 is equal to 0. So we place 0 here. And then comes this place T of 1 comma 2. Now we are just writing the values, that is now I is equal to 1 and J is equal to 2, and then the value of that particular item is 3 and the weight of the item is 2. Now we can substitute in this formula. So T of 1 comma 2 is equal to maximum of T of 1 minus 1 comma 2 comma the value of the item plus T of 1 minus 1 comma J minus, that is 2 minus weight of the item. That is maximum of T of 1 minus 1 is 0 comma 2 comma 3, value is 3 plus T of 0 comma 2 minus 2. So the resultant will be, you will have maximum of T of 0 comma 2 comma 3 plus T of 0 comma 0. Now we have to see T of 0 comma 0 is 0. 0 comma 0 is 0 and we have the value is 3. And then you will have the T of 0 comma 2. 0 comma 2 is again 0. Now we have to find, we will be having the values as 0 and 3. So the maximum of 0 and 3 is 3. So we are placing the value 3 here in this particular cell. Similarly, we'll find the value to be placed here, that is 1 comma 3. Now we have the values, that is I is equal to 1, J is equal to 3, and the value of that item is 3 and weight of that item is 2. So we are just substituting all the values inside the formula. So here we are substituting the formula, that is 1 comma 3 is equal to maximum of T of 1 minus 1 comma 3 comma the value of the item plus T of 1 minus 1 comma 3 minus weight of the item. That gives maximum of T of 1 minus 1 is 0 comma 3 comma the value is 3 plus T of 1 minus 1 is 0 comma 3 minus the weight is 2. So 3 minus 2 is 1. So here maximum of 0, that is T of 0 comma 3 is 0 comma 3 plus T of 0 comma 1. So here you can find T of 0 comma 1. 0 comma 1 is 0. So that you will find, you will have maximum of 0, 3 plus 0. So 3 plus 0 is 3. So maximum of 3, 0 is 3. So here in this place also we will have the value 3. And then we will find the place 1, 4, t of 1, 4. Similarly, we will have the values I is equal to 1. Now j is equal to 4, and the value of item is 3, and the weight of the item is 2. So we will substitute all these values in this formula. So the substitution gives like t of 1, 3 is equal to maximum of t of 1 minus 1, 4, value of that item plus t of 1 minus 1, 4 minus weight of that item. So here we have maximum of t of 0, 4, the value is 3 plus t of 0, 4 minus 2. Now t of 0, 4 is t of 0, 4 is 0 here. So we place 0, 3 plus t of 0, 2. 0, 2 is 0 here. So we have 3 plus 0. 3 plus 0, which gives 3. So finally, the maximum of 0, 3 will give 3. So t of 1, 4 is 3. You can find here. You can place here. And now we will find the value to be placed in 1, 5. T of 1, 5. So we will write all the values of 1, 5. I is equal to 1. Now j is equal to 5. The value of the item is 3 and the weight of the item is 2. So we are substituting the values in the formula so that t of 1, 3 is equal to maximum of t of 1 minus 1, 5, the value of the item plus t of 1 minus 1, 5 minus weight of the item. So that gives maximum of t of 0, 5, this one, 3 plus the value is 3 plus t of 0, 5 minus 2. Now, t of 0, 5 will give 0. You can check in this table. T of 0, 5 is 0. So it is given 0, 3 plus t of 0, 3. T of 0, 3 is 0, 3 is 0. So 3 plus 0 gives 3. So maximum of 0, 3 will be 3. So here we will place 3. So likewise, if we follow the same steps, same formula, substituting all the values for the remaining these items 2, 3, and 4, finally the table is filled with these values. And now we have to find the maximum profit and what are all the possible items that are carried inside the bag following the conditions. That is, the maximum weight, it should not exceed the maximum, it should be less than or equal to the weight of the bag, and also it should produce the maximum profit. So for finding this, we have to backtrack from the last step. So when we backtrack from the last step, we can find what are all the possible items that are carried so that it produces the maximum profit. And also it carries the actual weight of the bag. Now, the last value you can see here is 7. So when we backtrack, we have to follow certain procedure. Now, just check whether this 7 is present in the previous row. When it is present in the previous row, then we can directly go to the previous row. Now again we have to check this 7 is present in again the previous row. Here also the 7 is present. Now again we have to check this value 7 is present in the next previous row. So here we are not finding any value of 7 in this row. That means this, by including this item, we got the value 7. So I repeat again, by including this item 2, we got this maximum profit as 7. Now, we have the value or the profit of this item is 4, so that we can subtract this 7 minus 4, so that the remaining profit will be 3. 7 minus 4 is 3, so the remaining profit is 3. So that we have to find the value 3 in the previous row. In this row, whether 3 is there. So here also you can find 3 is here. Now, we have to check whether 3 is present in the previous row. So here we don't find 3 here, so that we have entered 3 by including this item, item 1. So by including item 1, we got this value 3. Now again, we can subtract the profit with this item's profit, which is 3. So 3 minus 3 is 0. Now, finally, you can see that by adding item 1 and 2, we can produce the maximum profit, which is equal to 7. And also, you can check the weight, which is 2 and 3 by carrying items 1 and 2. So when we carry item 1 and 2, the weight is 2 and 3, which is equal to 5, which is the actual weight of the bag. So from this, we can find the maximum profit is 7 by carrying items 1 and 2, and the weight of these items is the weight of these items are 5. Thank you for listening. Have a good day.